Good evening, everybody. My name is Jose Romero. I am one of the adult services librarian here. My reasoning to bring David A. Robinson here to this panel is because of the natural occurrences that are happening right now in our own state. David is a distinguished professor of geography at Rutgers University and New Jersey State climatologist. He is a frequent speaker on issues pertaining to New Jersey's weather and climate. He is a contributor to the Intergovernmental Panel on Climate Change and the U.S. National Climate Assessment. Dave is a fellow of the American Meteorological Society and a recipient of American Association Geographers Lifetime Achievement Award. If we have questions after the presentation, I would like if everyone can put it in the chat box. I think that might be a smooth transition on that end. So without further ado, Mr. Robinson.
Thank you, Jose. It's wonderful to be here. A pleasure to talk about my favorite subject, and that's New Jersey's weather and climate. So with that, I'm going to just jump right in. I'm going to show you a lot of slides, so you don't have to look at me. Let's see. How are we doing? Everybody set there? I got to launch it, and then we'll see it. It's coming. It's coming. There we go. All right. So, as you can tell, as you might imagine, I talk a lot about Jersey weather, Jersey climate to anybody and everyone. It's a pleasure to be here tonight to talk to you folks. I am a professor, as mentioned, in the Department of Geography at Rutgers, a department that is intimately involved in looking at the interactions between humans and the environment, the impact of the environment on human beings, as well as the impact of human beings on their environment. And that includes social science and physical science realms where we all get together and work on issues. And I am a physical scientist. My training is in geology as an undergrad, Earth System Science as a grad student. I was at Dickinson College as an undergrad and at Columbia University, particularly at their Lamont Doherty Earth Observatory as a graduate student, where I spent several years doing research following my degree. And then 3 years ago, came down to Rutgers. And about 3 years after getting to Rutgers, I was appointed the state climatologist by the Dean of the Agricultural Experiment Station, also was known as Cook College at the time. It's through a gubernatorial declaration that the state climatologist in New Jersey should be at the land-grant university, Rutgers. So I have been your state climatologist for almost 31 years now, which, despite my very young age, makes me the longest serving state climatologist in the country. Tomorrow will be week 3 of our 4-week Friday state climate meeting for the nation. We hosted that meeting 6 years ago. Now it's second year in a row, it's virtually. We were down in Cape May 6 years ago. Anyway, it is something that's part of the service component of my work at Rutgers, as opposed to my teaching, where I teach classes in climate, Earth system science, even the geography of New Jersey, kind of writ large, satellite remote sensing and such. And then I also have a research program where I make my contributions more to national and international assessments. And that has to do with snow cover across the globe. That's been my research emphasis and my source of about 150 publications and a continuous amount of support from NASA and National Science Foundation and NOAA back to my grad school days. So enough about that, enough about me. This is where we're going. Don't worry, there's only a couple slides for some of these topics, a few more for others. But let's keep moving. I have a lot of fun whenever I go out and talk to different groups. I look into the town and grab some images. So there may be images in here, as you see, as we work our way through the outline, that you'll find familiar. Anyway, greetings from the Office of the State Climatologist. We are a service organization. We are here to help people make decisions. We will not make decisions for you. We'll give you the information and expertise to help you make an informed decision on whatever is relating to weather or climate, which when you think about it is just about everything: transportation, emergency management, agriculture, environmental protection, on and on, health, on and on. That's our website, njclimate.org. I'll tell you a little bit about parts of that in just a second. But I want to give you an idea of the type of things we'll talk about, inform people about, that I get interviewed about a lot. Here we are looking at last year's hurricane season in the top with lovely photographs of all the hurricanes that afflicted us last year. A record 30 named storms last year. We were impacted by several of them: Isaias, quite strongly, Faye, and a few others. They brought some strong damaging winds to the state, the worst since Sandy in terms of Isaias, along with 2 tornadoes. But they also brought us very welcome rains, which kept us out of drought conditions last summer that weren't too far away up in New England, where they missed the precipitation from those storms. This year, in the lower right, turning our attention to our hurricane season or tropical season that's already begun, we've had 2 named storms. Bill was this week off of Hatteras, moved off the sea up to Newfoundland. Didn't get much attention. It was very short-lived. Anna was a couple weeks ago. It was in middle of May. They're expecting a 60% chance that we'll go above the average number of storms, named storms, which is the average is 12 this year. To put it the other way, there's only a 10% chance that will be below average with the number of storms this year. There's a lot of things lining up. I won't go into it now. That's a whole other talk as to why we believe it's going to be an active hurricane season. It doesn't tell you where the storms are going to go and when they're going to come to wherever they head. It just, if we have 20 storms or 15 storms, the odds increase over if we have 5 or 10. But you have to remember, it only takes one storm. It only takes one storm to wreak havoc. So we can never let our guard down. So that's the idea of the type of information we provide. We're not meteorologists giving you the forecast. As climatologists, we can help interpret the weather forecast and also put a climate spin on it. How unusual is this? How often does it occur? What's the magnitude? What might we expect in terms of extremes? What are the odds of something occurring? So it kind of keeps us out of trouble, not forecasting the day-to-day weather. We also maintain what's called a mesonet, a high spatial resolution network of automated stations across the state. We have 65 of them, literally from a High Point Monument to West Cape May. And every 5 minutes, we gather a wealth of weather data from those stations: temperature, wind, precipitation, solar radiation at some, soil temperature and moisture at others. Anyway, every 5 minutes, we gather this data from these solar powered stations, send it via modem to the cloud now, where we put it out. Every 5 minutes, we put an update of maps, and you can click on these maps and get all these variables. You can pick your favorite local station and make it as your key. We also link in to Newark Airport and some other weather service stations. We do not have a station in Essex County, nor in Union County. They're the only two state counties of the 21 in this state that we don't have stations at. We have one at Jersey City, at Liberty State Park, at the Liberty Science Center. We have one out in Basking Ridge, right on the Morris Somerset County border. Up in, we're gonna have one go in Little Falls pretty soon on the campus of Montclair State. We'd love to get stations. We just need to get support for these, and we need to find good locations for these stations. This is what a really good one looks like out in Mercer County, the Watershed Institute. It's pretty simple. There's nothing exciting about the stations themselves. What's exciting is the information that's gathered from the stations. For instance, this is June 17th. The low temperature this morning at our station up in Walpack, which is up in Sussex County in a valley where the cold air just drains off the hillsides into it on a calm night. It was 34 degrees there this morning. And up in Stokes State Forest, at Standyston, at the School of Conservation, it was 37 degrees this morning. And we're in meteorologic, climatologic summer, which we start June 1st, but we're almost in astronomical summer. And we almost hit the freezing point at one of our stations this morning. This is just the type of information we gather. We have a link to, this is visible satellite data just yesterday. And yeah, I had to look at my calendar. I'm getting all the days straight. And you can see there were clouds here, but that's tens of millions of dollars worth of satellites. We have solar sensors on our stations. And at the same time the satellite image was taken, this was the solar radiation measured at our stations. You can see high values in the north and very uniform because the skies were clear. But where the skies were patchy, here was some sun, here was some clouds, here was some clouds. So if I look at this image, I'll tell you right away, it's partly cloudy. I call it the poor man's satellite image because it tells us a lot about cloud cover, obviously only during daylight hours. Now, visible satellite imagery only works during the day, but there's things called infrared imagery at night that look at the temperature of the clouds and the surface. And we have that on our site too, that link. We also have a volunteer precipitation observers program. Maybe some of you are weather geeks there, and maybe we have a CoCoRaHS observer here tonight, but the Community Collaborative Rain, Hail, and Snow Network is one of the premier citizen science networks in the country. We have 300 active observers in New Jersey, about 15 to 20,000 nationwide. And these observers purchase a standard rain gauge. Every morning they go out, breakfast time, look to see if there's any water in the gauge or it's dry. They go on their cell phone or on their computer and enter their data, and it goes into a national archived network. These are not from our automated stations. These are from all our volunteer observers. And you can see on this particular day, very heavy rain right up through the spine of the state, less to the northwest, much less to the southeast. And it really lets us get fine fidelity to where the rain is falling and not falling, which is important if you're looking at drought and agricultural issues. We report hail if it's hailing in the winter, immeasurable, pun intended, measurements of snowfall from many of these observers that we just simply don't have without these volunteers. So if you like to gather data, you want to see what you've got compared to your neighbor, we do have observers in Essex County and Union County and Morris and every county of the state. Salem's our weakest county there, but we do have some observers there. So it's really cool, really, really interesting data being gathered. And very useful too, I might add. So that's the state climate program. Enough about us. One slide, a couple slides about the Earth's climate system. Take home point here, it's complex. Number one, it's a system. Number two, that means everything is connected to everything else and is influenced by other parts of the system and influences other parts of the system. Now we can break it down. My research specialty is the cryosphere. I've looked at snow cover, snowfall, sea ice, since I was an undergrad. Just something that piqued my interest. I've been keeping weather data since I was in fourth grade up in Tenafly, New Jersey. But I just always had this interest in the cryosphere and snow and ice. I was able to make a career out of it. Not bad. And there's the biosphere and the hydrosphere, the lithosphere. There's something for everyone when it comes to studying the Earth's climate system. Even computer programmers, physicists, chemists, biologists, geologists. Oh yeah, atmospheric scientists as well, and even solar scientists, astronomers in a very broad sense. So, and look at all the parts of this natural system, and look at front and center. We've got human activities that are playing a role, not giving away where we're going here, that are involved with this global climate system. So more on that in a little while. So take home point, complex, interactive system filled with all kinds of opportunities to study and learn more about. How about Jersey's climate system, jumping right to home? Complex itself. I think it's wonderful. We have 4 seasons. I think it's wonderful. We have a wide variety of different weather and climate variables. I don't think it's so great when we have a Sandy, a blizzard, an ice storm, a flash flood. That's a stream with cars that have been pulled off a dealer's lot in Little Falls a couple of August ago. We sometimes get some big hail. We have fires in our pinelands when it gets too dry, and we have drought. But the neat thing about Jersey's weather and climate, while we get this wide variety, we tend not to get the worst of the worst. We get a taste of everything, but we generally don't have the worst wildfires. We don't have the worst ice storms generally. We generally don't have the worst tropical systems. Sandy was a biggie. Could have been even scenarios where it could even be worse. That was pretty bad and transformative. And we haven't had a major drought in this state since 2002, whereas all the Western US is in extreme drought right now. But we get a taste of everything. We tend not to get the worst of the worst, in part because we're near the ocean, which helps to moderate temperatures and severity of thunderstorms and tornadoes and such. But of course, being near the ocean, we can get the tropical systems, and it's an ample source of moisture for a flood or a flash flood. Just drilling in a little bit more within New Jersey, we have different climate regions of the state. Now, you can draw these lines a little arbitrarily as you wish, but essentially here we're talking the highlands, where you've got the deep valleys with the cold mornings like this morning, or the high mountains of New Jersey at High Point and up in the highlands. We've got the Piedmont, where we're sitting and talking tonight, all of us, where it's kind of a tweener zone. Sometimes we've experienced some of the inland effects. Sometimes we've experienced some of the coastal effects. And we also experience local urban effects, which can impact our climate, particularly when you get into the urban hotbeds, if you will, with urban heat islands in the Jersey City, Newark metroplex there, if you will. That can extend out to West Orange, but not always. In West Orange, I know you've got the higher elevations to the west and lower ones to the east, which can make a whole bit of difference on whether you're getting snow or rain in a particular winter situation. Then we have the sandy, unique biomes of the pinelands, the agricultural vegetation truck crop haven in the southwest, and of course, major influences of the nearby ocean right along the coast. Cooler in the summer, thank you, sea breezes, milder in the winter, thanks to less cold, shall we say, water temperatures compared to what we might find on land. So there you go, kind of a climate potpourri Moving on, let's see how that's varied past to present. Going to jump right to present. Well, first of all, let me talk about in general. I pulled back on some slides here as not to take forever. There was an ice sheet that came down through West Orange 20,000 years ago that ended down around Plainfield and then went across Staten Island to the Verrazano Narrows. Everywhere from there on north was covered. Manhattan with 2,000 feet of ice or more. High Point had 1,000 feet of ice over it. You can find grooves in the rocks atop High Point where the ice had boulders in it that scraped along the bedrock and gouged it out. So what a natural history and variability of climate in the state. Now, these things took tens of thousands of years to unfold. Then we work our way to shorter term variations. A volcano erupts and you can have an impact on global climate if it's the right volcano in the right location for a couple of years after it erupts. We have solar cycles that have some minimal influence in some parts of the world on a decadal 11, 22-year cycles. We have things called El Nino and La Nina. We just finished up a La Nina. We may go back to one this fall. El Nino is better known, and they can influence tropical conditions, but that has influences all the way up into the middle latitudes and beyond when they occur. So there's a lot of natural variability in the climate system that we have seen and documented in New Jersey going back tens of thousands of years. Now let's pull it jump up to the present. This shows you how climate conditions have varied across New Jersey in the last 12 months. This figure shows you the green bars are months where precipitation has been above average, going back to last June. The red bars are months when precipitation has been below average. You can find this on the state climate website. We update it monthly. We just updated the mean period in which we are deriving these departures. It's now 1991 to 2020 for the mean. Just until a month ago, we were looking at 1981 to 2010 means. I'll talk about that a little bit more in just a second. But this shows us that 4 of the last 12 months have had below average precipitation. The remainder of the months have had above, slightly to more significantly above, but none of them were in the top 10 for dry or wet compared to the last 126 years, going back to 1895 when Jersey records began. Now, turning our attention to temperature, you can see the red are warm months compared to normal, the blue are cooler months compared to normal, and you can see 9 of the last 12 have been above average in the temperature department. Of the 3 that have been below average, 2 barely made it. And cut ahead for a second, neither of those would have been below normal if we were using 1981 to 2010 normal temperatures. But since 1991 to 2020 normal temperatures are warmer, that actually put them down to below normal status. So in other words, it's harder to be above normal now because we've warmed so much in the last 10, 20, 30 years. And I'll show you more about that in a couple of minutes. And of these, you can see 3 of these months ranked in the top 10 of the last 126 years. And last summer was the 2nd warmest. Last fall was the 8th warmest. So we're cooking. We're cooking in New Jersey when it comes to our temperatures. This is the long-term temperature trend for Jersey-wide going back to 1895. And you can see we're warming at a pace of almost 3 degrees per century Fahrenheit, 3 degrees Fahrenheit. And you can note that a below average year in the last couple of decades, these points on this series are about the same as the warmest years in the 20th century. And the warmest years of this decade far surpass anything we saw in my childhood growing up in New Jersey, and certainly our grandparents and grandparents as well. So we are really warmed in New Jersey over the last century. And if we were to just look at the change going back just to about 1980, the rate would be closer to 4.5 degrees per century average. So we've actually the warming has sped up. Now, not every year is warm. Last year was the second warmest on record. 2012, excuse me, still is the warmest. This is the normals I was talking about. What they did here, they looked at the new 1991 to 2010 normals compared to the past. And essentially, whoops, excuse me, anything in blue was colder than the long-term normal. Anywhere in red is warmer than the long-term average. And you can see how decade by decade by decade, especially the 2081 to 2010 means and the 1999 to 91 to 2020 means, the whole country is warming at a very rapid pace, very different than what we found a century ago. Another way of looking at this, some people will say, yeah, but it was still 34 degrees this morning in Walpack, and we still get the cold weather that hit Texas back in February. Some of it, a little bit, made it over here. What about this warming that you're talking about here? Well, think of the distribution of temperature like this. This is from 1951 to 1980, grabbed temperatures from across the Northern Hemisphere and plotted them up. And this was their distribution. So mostly they were around here, but there were some cold reports and there were some warm reports, and very rarely extremely hot, very rarely extremely cold. This was the curve. Speed ahead and look back 2005 to 2015 to the same distribution of stations and plot those years up. And it's this curve. And in the background, you can see the shadow of this curve. So what this is telling us is that it's much more common to have above average hot days in this century. They were much rarer, and it was more common to have this type of weather just 50, 75 years ago. Extremely hot days are much more commonly found than they were in the past. But the but here is it can still get cold. It's just very difficult to get it cold. It's rare to get it cold because we've shifted the normal. And with that, our curve is over here now, but it still doesn't eliminate days that in the past would be considered normal, that now we consider them below normal, and some days that are much below normal. So this kind of figure, I say, when you're talking to your cranky uncle at Thanksgiving and they say, it snowed today, it's November, what is this? You can say, that's part of natural climate variability, but all the natural variability now is occurring at a higher plane, on a higher plane. We're seeing it this week out in this Western US, where all-time records are being shattered for June temperatures, in some cases for any summer month. And there was just something in the paper, I guess it was the Post today, that talked about, someone was quoted as saying, the average heat wave now is a couple degrees warmer than an average heat wave in the past. And that's enough to crank out new record highs. So it would have been hot in the past, we're just making it hotter. It would have been cold in the past, we're just making that cold less frequent and not as cold. So there we go. And we're talking atmospheric warmth here. This figure shows you the warmth that is being held within the Earth's climate system by the oceans. This is the warmth being held by the atmosphere. This is by the deep ocean. This is by the shallow ocean. Since about 50, 60 years ago, about 90% of the warming of the Earth is being held by the oceans. Despite the fact the atmosphere is warming, without our oceans, it would be just crazy, the amount of energy, the amount of warmth that would be in the atmosphere. So we're warming our oceans, our shallow oceans, and even our deep oceans. So if we were to just stop burning greenhouse gases today, we still have all that excess warmth in the oceans. So we're not going to cool off to pre-industrial, pre-anthropogenic levels anytime in the long, long, long future. I realize I'm jumping ahead a little by talking about the past. I'm leading us into the future. But before we leave temperature and the thermal side, it's very important to talk about the moisture side. We're a water planet. We need water to survive. I read an article today about why anthropogenically, why or physiologically, humans need more water than most creatures. I hadn't realized that. And it gets into an evolutionary process. But the fact is, we need water to maintain our health. We need water to grow our food to maintain our health, and so on. And therefore, and they're seeing that out west, where as hot as it is, the drought is even worse. But here in New Jersey, this is a long time series of precipitation. Rain and any snow that falls, we melt it down to its what we call its liquid equivalent. And you can see a lot of interannual variability, ups and downs. You can see the drought of the 1960s, 3 really dry consecutive years. You can see that 2011 was the wettest year on record until, whoops, I should say 2011. Sorry about that. 2011 with Irene was the wettest year on record until 2018 came along and surpassed it. So you just in the last decade, we lived through our 2 wettest years of the last 126 years. But you notice a lot of variability. You have to be prepared for it to be dry. You have to be prepared for floods. The climate system appears to become more variable, and it's expressing itself in dry and wet conditions. But overall, Jersey's getting a little bit wetter over the last century, about 6-7% wetter. And this is the normals for the country, just like we saw for temperature, but for precip. Now for temperature, you saw the whole nation getting red, warmer. The browns here mean it's getting drier. The greenish blue means it's getting wetter. So the bulk of the nation's getting wetter, but look at there, right in the southwestern US, it's getting drier. And you say, well, hold on. Yeah, it's desert there. No, what I mean is the dry areas are getting even drier. Witness the fact Lake Mead's at its lowest water level since it began to fill in the 1930s, and so on and so forth. So we're seeing the dry areas get drier, the moisture areas get moisture, and up here in the northern plains, even wetter. But is it enough to keep up with the warmth? Because when it's warmer, you evaporate more and you dry things out faster. So really, in order to keep crops growing in a warmer world, we're going to have to make it wetter or rely on irrigation, which of course depends on rainfall in the short term on the surface, or groundwater like the Ogallala Aquifer, which has been drained greatly here in the central part of the country, or aquifers in California, which have been drained horrifically. So I'm more worried about water for the most part than heat, except for the associated relationship between heat and moisture availability. And then extremes with warmer oceans, with warmer atmosphere. A warmer atmosphere, I should mention, can retain more moisture, higher levels of liquid in an atmosphere that's warmer. Not every day. Today was a mild day and it was very dry here in the east, but potentially with warming temperatures, more moisture available. So you've got more moisture, you got more energy, and with that, more extremes. Are we seeing this already? Perhaps, but when it comes to extremes, they're unusual. So you have to be a little patient as a climatologist before you can, say with utmost certainty, that's a trend towards more extremes. But if you look here at the Millstone River in Manville, back 5 times within the last 20 some odd years, going back to Floyd in 1999, 5 of the 7 largest floods on this river, just upstream from the confluence of the Raritan River, 5 of the 7 largest floods since 1921 for the century have all been in the last 20 years. This was Floyd, this was Irene, this was a nor'easter, a very vigorous coastal winter storm, late winter, early spring. Same thing here, and the same thing with this storm. I didn't get a photo there from the railroad bridge to the south end of Manville. You know, I literally, as a crow flies, I live about 2 miles from there now. I just moved closer this winter, but we're about 50 feet higher. Thank you. It's a very flood prone area, to the point where they've bought out dozens of homes in the most vulnerable part of town through Blue Acre funds and just leveled them and made it parkland. Thank goodness. They shouldn't have built homes there in the first place. And then we're a coastal state. We can't forget it. We got the shore. And with that, we look at sea level and we worry about what sea level is doing. And these are 2 tide gauges, one at Sandy Hook, one at Atlantic City. And they basically go back about a century. And they show you that sea level has risen about 1.5 feet in the last century. About 2/3 of that's because the ocean's gotten warmer, and warm water it takes up more volume than cold water. About 1/3 of it's because the land in South Jersey is sinking. Has to do with geology and back to the ice sheets being up north. But the sea level is rising primarily due to the warming of the ocean and some melting of glaciers, alpine glaciers, the Greenland ice sheet, a little bit from the West Antarctic ice sheet as well. So that's sea level. Now I've brought you up to present here. Now we want to look ahead at climate change and its causes. And I'll get through this quickly because we've kind of been there. I've already kind of spilled the beans. Climate change is real, it's happening, and it's affecting New Jersey. If all those observational figures haven't convinced you, I could give you more, but I won't tonight. But that only begs the question that, you know, is it changing? Yes. Of course, the next one is why? And the why comes down to humans being responsible for a significant portion of recent changes. Let's break that down briefly. Significant. Depends what variable you're looking at, depends what part of the world you're looking at, but absolutely incontrovertible evidence that humans are playing the major role with 95% certainty that the major impacts of climate variability and change right now are due to human activities. What does it mean recent? Basically, from 1980 on, you can discern a human impact on climate change. Up until about 1980, there was enough natural variability in the climate system that it was very difficult to determine if that variation was due to human activities, natural variability, a combination thereof.
No, I'm just watching something on my iPad. What is it? We have an 8 o'clock tonight.
Can you,
No,
Ruth?
okay, that's
So we
fine.
want you to notify everyone. So
Yeah, that I'll make dinner reservations.
Holly,
Um,
and I think that's
okay, great. Anyway, as I was saying, you still have natural variability these last 40 years. You can see when volcanoes have erupted. You can see when there's been an El Nino, but it's all occurring on that upward swing that can only be explained by human activities on the globe. And it goes to 3 things here. It's not just one piece of even observational evidence, and we've seen multiple ones. There's theory, this greenhouse theory. In a nutshell, If you're cold at night, you put a blanket on your bed. And that keeps the heat from your body from escaping into your bedroom as quickly as it would without a blanket. Now, eventually, it will escape the top of the blanket, or you're going to burst into flames at some point during the night. But it holds that heat near the body. If you're still cold, what do? You put another blanket on, and that holds the heat in close to you a little longer. And that's essentially the greenhouse effect. Now, the heat is coming from the sun that's heating the surface of the earth, and that heat is trying to get back out to space. So we have a balance of in versus out. Well, what's happening is it's harder to get out than in. That outgoing heat, radiative heat, is absorbed by gases in the atmosphere called greenhouse gases, carbon dioxide, methane, and the most prevalent of all greenhouse gases, water vapor. And that's our blanket. So we would not have a habitable planet without a natural greenhouse effect. We'd be basically 0 degrees Fahrenheit. That's the amount of energy the sun provides the earth. Without an atmosphere, we'd be an ice cube. But because we have that atmosphere, we heat up to about 59, 60 degrees Fahrenheit on average. So what we're doing is adding another blanket, a thin blanket, that is starting to raise the temperatures above that 59 or 69 degree global average. So think of it as just putting another blanket on a bed, but it's theory. You have to throw physics out the window not to observe that with more greenhouse gases from the burning of fossil fuels, for instance, you have to throw physics out the window if you say that can't warm the planet. And then we have models, sophisticated numerical models run on the world's fastest computers that are used to forecast our weather. And before you jump in there, weather forecasts are incredibly accurate. A 3-day forecast today is as good as a 1-day was 20 years ago, and a 5 days better than a 3-day was. But they're not perfect. Nothing's perfect. But these models are run on climate time scales. And that's our crystal ball. That's our look into the future. And speaking, so first I'll just show a couple of these non-natural mechanisms. I mentioned greenhouse gases and carbon dioxide rising. We also put a lot of dust and dirt in the atmosphere. Some of it helps to warm the planet. Some of it actually helps to cool the planet, and it partially counterbalances the greenhouse warming. We got rid of all the dust humans put in the atmosphere from agriculture and some burning. We warm even faster. And we deforest the surface, and we change surface characteristics, which change their ability to absorb solar radiation, and involved with evapotranspiration, plants and such. So we do a lot. And these are just some of the mechanisms. Whoops. This shows you these climate models. They're run in the atmosphere, they're run in the ocean, they're run on the land surface. They're now called coupled climate models. Modeling was in its infancy in the 1970s. And it's just kind of at middle age, but it's amazing in my career how models have evolved with the speed of computers, with programming and our increased knowledge of the planet. But they're not perfect either, as I mentioned. So with all of that knowledge and what's going on, let's take this home in the next 10 minutes here. What's the future? Are we doomed? I'm not going to leave you feeling that bad. I'm going to leave you feeling a little worried, a little concerned, but hang in there. What about our climate future? Take it to the bank. New Jersey's going to keep getting warmer. Now, I didn't put how much warmer. Some models suggest by the middle of this century, a couple degrees. By the end of this century, maybe 5 degrees. Some models suggest maybe 9 or 10 degrees warmer by the end of the century. 9 or 10 degrees would put us down to like Georgia. 3 or 4 degrees would put us to Richmond, Virginia. in a sense, to put it into perspective. We're not suddenly going to be growing palm trees like Miami or anything like that. Why this wide range? Are the models that bad? Well, the models do vary, and there's a couple dozen models run globally now from different countries and within this country. The key to why we can't zero in on numbers better, it's you and it's me, because we don't know future, what we call emission scenarios. Are we going to get these greenhouse gas emissions under control, or are they going to still just run wild? Are we going to go green? Are we going to have business as usual? So we run these models with different emission scenarios, from a very positive one to do nothing one, and then ones in between as well. And that's why we have such a wide range of temperature as we get to the end of the century. Now, almost all the models show a couple degrees warming by the middle of the century. That's almost set in stone. But all the models show that what we do right now is going to have a big impact on what things look like in the second half of this century. Now, try to tell that to a politician who runs on a 2 or 4 or 6 year cycle, or tell that to anyone for that matter. It's tough to process, despite you might have my 3 grandkids are right back there in those photographs. They're anywhere from 6 months to 2.5 years. They're going to be around at the end of this century. What kind of world are they going to see? Are they going to see a world based on these high scenarios or these low ones? We don't yet know, but we know temperatures are going to continue to rise at some pace. In the Northeast, we think precipitation is going to be steady or maybe increase some. And as I said, we hope it increases some in a measured way, not in flash flood way, because with rising temperatures, we need more moisture to keep things moist. Increasing variability. I've already talked about more energy in the system, more storms, more flooding, more heat waves, and yeah, more drought. And then you're going, oh, Robinson, you wanted everything. You're talking about more drought and more floods. What do you want? Everything? You just put down everything you got, you son. Think about this. We have a lot of moisture available in a warmer atmosphere with the ocean nearby. And if we find a trigger, an atmospheric trigger to help wring that moisture out of the atmosphere, look out below. But we can have all the moisture in the atmosphere we want. But if we don't have that trigger, it's going to stay in the atmosphere. And the sun's going to keep beating down. And that's going to dry out the surface. And a drier surface is going to result in less moisture in the atmosphere. And you're going to get drier and drier and hotter, as opposed to getting that trigger there where you get wetter and wetter, which might actually keep the temperatures a little under control with cloud cover and such. So that's what we're worried about, a streakier type of environment. I mean, it's not a great example, but look at the last couple of months. We've had 2-week dry spell in March, and then it got wet. We had a 2-week dry spell in May where things were really starting to get dry. And then along came some heavy rains the Wednesday before Memorial Day weekend. And of course, Saturday and Sunday, Memorial Day weekend, I spent dodging raindrops at Cape May. But it was liquid gold in some respects for the agricultural community in the state, and even to keep water resources okay. So we're okay right now with water resources, where we were worried 3 weeks ago, 4 weeks ago. So more variability. Okay, and then rising sea level. So rising sea level. This is an aerial view of Seaside Heights. And this shows it essentially with about a 1-foot rise in sea level. All these areas in light blue, and there aren't many, will be permanently underwater. Now they're above water. Now you raise sea level 3 feet and you got a big difference. That's where things really start kicking in. And all the Back Bay area, most of the Back Bay area is permanently, not just during Sandy, not during a nor'easter, permanently underwater. And with an outside chance of a 6-foot rise by the end of this century, your barrier islands, we're not going to be able to fight it any longer. We can fight it for a while with beach replenishment and natural shorelines hopefully coming into play, and yeah, some more hard structured breakwaters and things like that. But 6-foot rise, we're out of the coastal communities and we're backing up inland. These are the scenarios. Again, a 5% chance. Doesn't sound like a lot, but if I told you, well, you had a 5% chance of your home catching fire this year, I think you'd go out immediately and check your homeowner's policy to make sure it's in effect, or your car insurance for that matter with automobiles. So, we're talking odds. It's a very probabilistic subject, but everyone has to make a decision based on that, because we're all part of society and a community. But there you go. There's the outlook for the future. What will the impacts be? Just a couple slides now. Health, ag, forest, water, coastal biomes and inland biomes, species and natural variability. All of these are being impacted right now. I talk to health officials. They tell me how insect-borne diseases are having longer seasons, or they're seeing these vector diseases winter over, where it's not as cold in the winters as it used to be to kill off the invasive species. And that brings us down to vegetation and biota and such. The forest, they'll talk about the southern pine beetle that's decimating parts of our pinelands. It's a beetle that doesn't like temperatures below 0 Fahrenheit. And that can kind of get rid of all the eggs. We're not below 0 Fahrenheit, even in the pinelands, like we were in the past. It only takes a couple of nights of winter. They're not there. Things like that. We're already seeing these impacts. And these people are telling me what's going on. I don't have to talk to them and say, you better watch out for this, better watch out for that. They'll go, been there doing that right now. So what do we do about it? Nothing. Let me say right here, this is where I take a leap into the preachy phase, if you will. This is where science meets social science. And these are just my opinions, some thoughts on what we might do to face these challenges. First of all, we have to all get on the same page that these changes are happening. Humans are responsible for these changes. And we're going to be working with a natural climate system that's operating on a whole different platform now. And the better we understand this and all agree on this, the better we can, as a community, address this. And that's when I always thank people who come to these lectures and sit through my babbling, because maybe you've learned something tonight. I sure as heck hope you have, because you'll have a better understanding now of what we're facing and why we're facing it, and maybe start thinking more about what we can do about it. So with that knowledge in hand, notice just one last thing. I said knowledge. People ask me, do you believe in climate change? And like, oh, don't ask me that, because you're going to get a lecture from a professor, because it's not a matter of believing in climate change. Understanding is here, believing is here. And I'm all for believing in certain things, but this is an understanding. This isn't a belief. This is based on firm physical science. So anyway, mini lecture there. Knowledge. We need to mitigate. If we're going to address this issue, we have to know, we have to go greener. We have to use less energy. We have to use cleaner, greener energy. I was on a webinar yesterday on offshore wind. I've been involved with it a little bit with our marine science folks at Rutgers. I don't pretend to be an expert here, but it's one alternative. It's not the only alternative. There's a big debate that's every once in a while percolates up, and I'll let you decide on your own from your understanding of nuclear energy. Jersey, if we cut out New Jersey's nuclear energy right now at our power plant down in Salem, we'd be burning a lot more natural gas and might have to go back to burning coal in Jersey to get our electricity. But we know the dangers with nuclear energy. But there are some, including people I know who are fervent proponents, spoke for decades about climate change and how humans are involved, who are saying that that is one means of remedying, one way of mitigating things. So there are these ideas of mitigation. There are others out that are trying to geoengineer the planet. Put a false volcanic veil up in the stratosphere high above the weather that will cool the planet some, like a volcanic veil can after a major eruption for a couple of years. Now, consequential feedbacks on that could be odd distribution of temperatures and a big impact on rainfall patterns. We just don't know. This is an experiment we worry about. There's others who want to harvest the carbon dioxide from the atmosphere. Right now, it takes more energy to do that than it would save in greenhouse gases. And then where do you put it? Just like nuclear waste, where do you put it? But there's all these ideas of mitigation. But we're not going to fully mitigate ourselves out of this situation. We're going to need to learn to adapt. The buzzword these days is be more resilient. And we learned a lot about that in the post-Sandy period, these last almost 10, going on 9 years, to become more resilient. And this, I think, is a good lesson where we can merge the short-term hazard adaptation and mitigation effects with the longer-term climate ones. And we don't have to look at one here and one there. It's a continuum. And if we become more resilient to these major storms that could occur this year, next year, within this decade, we'll also be better prepared for what future climate change will bring as well. I think that's real important for this continuum to be in force, in place, and get an understanding of that. And then finally, we have to get out there, activism, leadership, raise public awareness. I'm very fortunate to have a platform like you folks tonight and dozens of others I speak with each year, and the media who I talk to, and my research that is studied globally, and my students who have to sit through this for entire semesters talking about climate and climate change and get a grade. There will be no test after this tonight. But we need to be active. If you feel something about this, get on your local green committee, practice at home. There's so many different ways of approaching it, but ultimately it comes down to one 4-letter word: vote. Look at the platform of the candidates. If this is something that really is important to you, look at the platform of the candidates and vote accordingly. If you don't vote, you don't have a say. You're not getting a say in this matter. So anyway, that I told you it was a preachy slide. That's my preachy slide. So let's just sum up. New Jersey has what a wild, interesting variety of weather and climate. Climate is changing in New Jersey. It's always changed, but it's changing at a very rapid pace now that cannot be explained by any natural mechanisms. And that change is going to continue, essentially no matter what we do, but we have ways well, I'm jumping ahead, and we think it's going to accelerate. We're on an upward swing at a faster rate. And with that, watch out for more extremes. And with that, of course, there'll be more impacts. But, and here's the hope, that there's time for mitigative and adaptive actions. I like to say the train has left the station. It's not going back, but we can have some control on the throttle. Just how fast that train's going to move forward is something we still have the power to control to some extent. I like to think that we were smart enough to get ourselves into this mess. We invented the combustion engine and mining techniques, and we evolved as an industrial society globally. albeit some people have not, and they're paying the consequences of it. There's big environmental justice issue there, folks. But be that as it may, we have been smart enough to get ourselves into this mess. I'd like to think that we're going to be smart enough to at least help manage this and maybe ameliorate it in some respects. So I want to leave you with that hope, that it is not hopeless, that there are things we can do to address this issue. But the faster we address it, the better it's going to be for you, the rest of your lives, your children's lives, your grandchildren's lives, and so on. And with that, did it in an hour?
Yes.
I'll answer questions. I know some of you have to leave, no doubt, but I'll hang on until the last question's answered. Thanks very much.
Thank you, David. Thank you so much. David, I got one question if I may ask you.
You maybe ask me, of course.
Okay. Now I think up in North Jersey, we have water reservoirs, correct?
Correct.
Does South Jersey also have reservoirs?
The reservoir in South Jersey is under your feet. It's the Cohansey Aquifer. It's groundwater in South Jersey. In North Jersey, it's groundwater and surface reservoirs.
Oh.
So the groundwater in this, there's a couple trillion gallons of water down in South Jersey, down deep. And interesting, Philadelphia tried to get in to mine that well over a century ago. And Jersey said no.
Right.
That's a real good thing. But you still have to get the water out of there. And it's taken thousands of years to fill that aquifer. In North Jersey, it's a much faster system, in and out.
Right.
And I will tell you straight up, New Jersey has woefully inadequate water supply. We have to count on average to above average precip to keep us out of trouble. And not to be a know-it-all, but I'm the one academic that sits on the New Jersey Department of Environmental Protection's Drought Task Force. And guess what? The Thursday before Memorial Day, we met. Now, we had some rain the day before, and it seems like
Right.
whenever we meet, it starts raining. So that's a good thing. But we were already not ready to do watering restrictions or anything like that, not to go to a drought warning or a drought emergency, but it was getting critical enough in early summer that we were worried and had to continue. Let's go theoretically. And
Right.
we're still sitting with a pretty, depends where you are in the state, a pretty dry to wet June. But let's say it had stayed really dry. By July 4th, we would have had watering restrictions in some communities, and then it might have become within 6 drought regions in the state. It could have been an edict issued from DEP commissioner. And then when it gets up to the warning and emergency stage, the governor gets involved. Now, we've been to warning stage a few times since the early part of this century, but we've not been to an emergency since the McGreevey era. I
Right.
stood next to McGreevey when he lifted the emergency back in 2002 or something. So we've been very fortunate. It's not like we're overdue.
Right.
Climatologists hate that term. We've just been very fortunate. And I can't help but think maybe that's because we've had more streakier precipitation, because we're seeing these extremes from what we call flash drought to excessive precip that might
Right.
keep us away from long-term drought, but we can still suffer crop failure. 2010 was a very hot, dry summer. It was massive crop failure. So, but as far as drinking water goes, you can drain these reservoirs pretty quickly.
Yeah. That's what I feel that when I hear things on the news talking about no drought, but there might be a possibility.
Yeah, I mean, right now we're okay. The Northeast is okay, and it was looking bad even again up in New England just a couple of weeks ago. But we've had plentiful enough rains. But come summer, they get very streaky. In the last week, one of our Kokoras or one of our automated stations has recorded 3 inches or more of rain in one day.
Right.
Normal for the month of June is about 4 inches. So they've
Right.
gotten almost, but I've only had 1.33 inches at my house the whole month.
Right.
And next door, a town over, 2 towns over me. So it gets very streaky. But at least people don't put as much water on their lawns. And
Yeah, true.
and some communities up in North Jersey, upwards of half of the water use during the summer is put on your lawns and gardens.
Yeah. I think Susan has a question, Dave.
Great.
Yes, hi. I actually saw something, well, in the Times recently, and it's just kind of what you've been saying. The projected future is that the West is going to be drier, and like pretty much the eastern half of the country is going to be wetter. And I'm just wondering, there probably are other solutions like, Jose said something about, ocean water desalination, but I'm just wondering if there's any way that we could build some kind of a canal or something to send water to, California and Utah. We have sometimes too much and they don't have enough.
Yeah. You're an engineer at heart. They actually, in China, they put water from the south and they pump it up to the north towards Beijing and whatever.
Oh.
But this is already done.
Oh.
And it's done in the Southwest, except there the water is mostly delivered by the Colorado River into Lake Powell and Lake
Right.
Mead.
I was just in Utah and the Colorado River is, kind of kaput at this point.
Yeah, they didn't have the best snow season in Colorado this year, and it was really bad in the Sierras, which feeds in a lot of California. That would be an incredibly massive undertaking. I've had someone, every time there's a public hearing, it seems like in the last 15 years, when we get into a drought concerns and there's a public hearing, someone several times has come up to me and said, well, why don't we just run a pipeline from Lake Ontario down to New Jersey? It's not the craziest idea in the world. Lake Ontario is a big, deep lake, but it would be very expensive. And then the desalinization. There are some plants out in California. Actually, Cape May has a desalinization plant because they can't meet the demand pumping it out of the ground fast enough in the summer with all the tourists there. And then Israel, a huge portion of their fresh water now is met through desalinization. It's expensive, but like in any resource, it depends on what the demand is and the price. And if you have a high demand, you have to have a high price and so on and so forth. So desalinization may be one way to look in the future for coastal areas, but that comes at a very high price, and humans use a lot less fresh water than out west, say in California, they use for agriculture. And that would raise, you imagine what you'd be paying for your fruits and vegetables when it comes
How about if we just, I would do it. How about if we just stop with the lawns?
Yeah, well,
Can we just do that?
Las Vegas actually just passed an edict that all non-essential lawns have to be eliminated in Las Vegas by 2027 or something. Now, what's non-essential? It's not golf courses.
Golf courses are not essential?
No, golf courses are considered essential.
No, I would grant that.
And they use a huge amount of water. And some people's yards, somehow they consider essential, but they're looking into more xerophytic landscaping. And the suburban areas of the East are into their lawns more than when you get further away from the suburbs. I lived in Nashville, North Carolina, up in the mountains where the National Climate Center was for a year. And no one worried about their lawns being perfect. They had lawns and such, but it was not a lot of lawn irrigation there. So it's a cultural thing in some respects. And frankly, it's a lack of knowledge. People way overwater their lawns in Jersey. And we worked with Suez Water on a smart lawn watering initiative, telling people when it made sense to water and how much to water. And Suez pulled the money out from the program, and DEP won't fund the program. So we've got all the software to do it, but we just can't afford to do it.
Well, what could I do? Like, how could I tap into that? I mean, I know that my lawn guy has sort of, driven by and rang our bell and said, you have to water more. So
your lawn needs about ideally an inch of water a week to stay green. And people tend to put 2 to 3 times that much on it because they don't let Mother Nature take it. They don't have a rain gauge. If you have a rain gauge and you see a half an inch of rain has fallen, don't water your lawn tomorrow or the next day, maybe even the third day, depending on how hot it might be. But people don't take that into account. It kills me when I see sprinklers on while it's raining or the morning after a rain. There's just no need for it. So I think we have a more educated, Susan, you asked great questions. I mean, a more educated public. And you don't have to get our fancy $35 rain gauge. A hardware store or whatever sells these little plastic gauges. And just think about it. You only need 30 minutes of water on your lawn a couple days a week if it's not rained at all, and then subtract from that any rain that does fall.
does that rain?
Yes.
And you'll use less water, and your lawn may be healthier, because people who water every day or water too often, the roots don't go deep. The roots come to the surface and they're a lot easier to burn out. So you actually have a healthier lawn if you stress it a little bit. And the roots have to reach down a little deeper to get the moisture. So I'm not, a lawn surgeon. I don't mean to take that business, anything out of business, but people just have to be more aware.
Yeah. Dave, I want to ask you another question. There was, in Mexico, there was a church that was found, but it was underneath a lake, but the lake dried up and they found this church. Did you hear about that?
No, that one I haven't heard about, but my question would be, is it a natural lake?
Right.
Is it a man-made reservoir, and because of a drought, it's gone dry and the church has reemerged?
Yeah. I just said, wow, all that water just gone.
Yeah. Well, just this week, I read out in California, a reservoir has gotten low enough that it hasn't exposed it, but they're able with sonar or whatever to get down and found what they're almost sure is an old Piper Cub airplane that crashed and disappeared, I don't know, 30, 40 years ago. And they think it's that plane, and the water had been too deep for on the surface sensing of the bottom of this lake until just this week or recently.
Wow, that's interesting.
It really is interesting. So
Does anybody have any other questions? No?
they're all too depressed. I've made you all too. Don't get depressed. I mean, it's worrisome. Don't get me wrong.
Yeah.
This is a serious subject. And it's one of our doing, and one that it's one of the most important subjects of the day. And I don't say that just because it's my profession. That's why I find great value and worth in doing what I've done, because I feel it's important. And it's nice to feel that way. But I also long for the days when I was in grad school where I kiddingly say people thought a climatologist mixed drinks or something like that. Now everybody knows it, to the point where I've got to become a political scientist, where I've gotten hate mail on occasion. But in the same sense, it's important that we're out there looking at this issue and talking about it. But we can't just talk. I can talk. I'm a professor. I can talk forever. But we have to do more than just talk about it. We have to do something about it.
Right. True. David, I just know one thing before we close, is that I don't go to the shore or in June or July, but I usually wait till September because the water is much warmer. It doesn't seem like there's global change there.
Well, no, I mean, that's part of the natural cycle. The warmest month of the year in San Francisco is September because the water's gotten a little warmer off the California coast, other reasons too. But yeah, the closer you are to water bodies, the later in the season you hit maximum warmth. So yeah, I didn't go to Cape May Memorial Day to go swimming, just to kind of go get out. But I didn't expect record low maximum temperatures.
Right.
There's a value. It didn't get out of the low 50s in the state, and those are records for the lowest high temperatures for those dates. So I mean, what are you going to do with that? But again, that's part of that curve I talked to you folks about.
Exactly.
This week we're real cool in the east, partially because it's so darn hot in the west, and the jet stream is gone kind of wild.
Right.
So, buckle up. It's going to be quite a ride as we go in the future.
Well, I want to thank you, David. I really do. Sincerely thank you for your presentation. And I thank our audience also for being here and participating. And have a good night, everybody.
Yeah, be well. Have a great warm summer.
Thank you.
Thank you, David.
Thank you.
Thank you, Dave.
Bye-bye
Thank you
all.
so much.
Take care.
Thank you. All right.